Put the heading as equilibrium of forces. Okay. First point, we can classify forces into two groups. Classify forces into two groups. Classify forces into two groups. First one is concurrent forces. Concurrent forces which meet at a given point, after extending. Next, non-concurrent forces. Non-concurrent forces which do not meet at a given point. Okay, so concurrent, non-concurrent. Now put the subheading as equilibrium of concurrent forces. Equilibrium of non-concurrent forces. Concurrent forces. Equilibrium of concurrent forces. Right? Equilibrium means the vector sum of all forces. The vector sum of all forces acting on the body should be zero. Suppose there are four forces acting on the body, so I can write F1 bar plus F2 bar plus F3 bar plus F4 bar is zero. This is zero. Suppose I don't know F4 bar, so F4 bar can be written as minus of. Now this is how we calculate the unknown force which is not given in the question. I can say summation of all the forces are zero. F1 plus 2 plus 3 plus 4. So if I don't know F4, I can calculate F4 as minus of sum of all the forces. When I'll do the numericals, you will understand at that time. Just write right now. Next point, there are three methods to solve. There are three methods to solve a problem of concurrent forces. Okay. Method 1. Represent all vectors in terms of I cap and j cap. Represent all vectors in terms of I cap and j cap, and then put their resultant as zero. Put their resultant as zero. Next point, Method 2. Method 2. Take any two mutually perpendicular directions. Take any two mutually perpendicular directions. That is x and y. Okay. Next point. Now resolve all the forces. Now resolve all the forces along x and y direction. Along x and y direction. Now put summation fx is 0 and summation fy is 0. Yeah. Summation fx is 0 and summation fy is 0. Okay, this we used to do in circular motion also. Remember, up is equal to down, left is equal to right. T cos theta balance mg, T sin theta provides the necessary centripetal force. Okay, this is method 2. Method 3. This method is only valid. This method is only valid for 3 concurrent forces. For 3 concurrent forces. And it is called as Lami's theorem. It is called as Lami's theorem. Lami's theorem. Suppose if I tell you 3 concurrent forces are meeting at a certain point. Okay? And the angles are alpha, this is beta, and this is gamma. Okay? Then F1 upon sine beta, F1 upon sine beta is F2 upon sine alpha, F2 upon sine alpha is F3 upon sine gamma. Are you understanding? F1 upon sine opposite angle, F2 upon sine opposite angle, F3 upon sine opposite angle. Are you understanding? This is called as Lami's theorem. Okay, so if I draw F1, F2 and F3, F1 bar, F2 bar and F3 bar, okay, can I say F1 bar is this way? F3 bar is this way. If I draw F3 bar is this way. And if I tell you F2 bar is this way. Getting it now? Everyone? Remember this, in mathematics we have done a rule called a sine rule. A upon sine A, B upon sine B, C upon sine C. This is derived from that one. This is Lami's theorem. We just need the application over here. That F1 upon sine beta, F2 upon sine alpha and F3 upon sine gamma. And this will solve only those 3 concurrent forces which are present at a certain point. If more than 3 are there, you can't use Lami's theorem. Then you have to go to method 2. I will generally avoid method 1 because you have to express everything in terms of I cap and J cap and then equate it to 0. That also we can do, no problem with that. But I'll use method 3 and method 2. Okay, write this, then we'll do with examples. Getting it now? What's happening? Now, we'll start with some examples. Example 1. Let's look at this. 60 degree and this is 45. Yeah. This is 1 and this is 2. And the mass is given as 2 kg. How many normal reactions are there? 2. N1, N2 is equal to how much? Don't know. I'll draw N1, N2 and the weight. You know weight will act. Two into G, na? Weight will become mg, na? 20 Newton. Yes or no? Where will the normal reaction be there? Normal reaction is perpendicular to the surface. So N1 is going to become this way. And N2 is going to become this way. Right, na beta? And this angle, this is 45. This will also be 45. Angle between two lines and the perpendiculars are the same. This is 60. This will also be 60. Right, na beta? Now I need N1, N2. How many forces are acting at a given point at the center? 3. Can I use Lami's theorem? Yes. If I draw this point, if I concentrate the whole mass at the center and I take this point, so how many forces are acting at this point? W? It's 20 Newton. This will be N2. And this is going to become N1. Look now. This is what? 105. Now you know this is 30. And this will be how much? 45. So this whole thing will be 90 plus, na? Look now, Baba. So this angle is 105. This angle will become 30 plus 90. It will become 120. And this angle will become 135. Now using Lami's theorem, W by sine 105 is N1 by sine 135 and N2 by sine 120. W is given as 20. Sine 105 will become 90 plus 15 will become cos 15, right? Yes or no? N1 sine 135 cos 45 and N2 cos 90 plus 30, na beta? Now cos 15 will be given to you in the question. It is 0.96. Okay, this will be given 20 0.96. This we know. See, N1 cos 45 is 1 by root 2 will become 0.707. N2 cos 30 is what? Root 3 by 2 will become 0.866. Now equate 1 and 3 and 1 and 2. Are you understanding what's happening? Start writing. Come on, fast please. Just pay attention. A sphere is given resting against a wall. Mass is 4 kg and L is equal to R. Find T and N. So they are telling you that this length of the string and this R is the same. Okay? You are understanding what's happening? And they have given you that mass is 4, so weight will become 40. Right, now? Can anyone tell me if I take this angle as theta? It's 90. So how much will be theta? Can I say sine theta will become R, but R is L by 2L. Look now Baba, sine theta is L by 2L. L plus L. So how much is theta? It's 30. So this will be 60. Right or not? Now where is the normal reaction coming? From the wall. So normal reaction will become this way. Where the tension? Tension is here. If I concentrate the whole sphere at the center, this will be weight W. This will be the normal reaction. And this is going to become the tension. Yes or no? This is 90. Okay. This is going to become 60 plus 90, right? 150. This will become how much? 120. You can apply Lami's theorem and get the answer. Come on, start please. W upon sine 120 is N upon sine 150 is T upon sine 90. W is given as 40. E cos 30. Cos 60 upon 1. T is Newton, N is Newton. Is the answer. This. I'll show you we can't use Lami's theorem over here. Lami's theorem is only valid for 3 concurrent forces at a given point. How is this going to be? Can I say the tension over here in this string, let it be T1. 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 And the tension over here in the string, and the string is different, it will be T2. Right, now beta? We know this angle is alpha given. So this angle will also be alpha. Is given as beta. Right? Now we are going to resolve the forces at given point. How much is the weight of this? 2 mg. Weight is 2 mg. Right? Can I say if this is T1, what will be this force? T1 cos alpha. As will be how much? T1 sin alpha. Correct na beta? Actually, you know one more thing. If this is beta, this will also be beta. So this will become T2 sin beta, and this is going to become T2 cos beta. Correct? We'll come here. Weight is mg. T2 cos beta and T2 sine beta, and this is the force which is applied, that is mg. Now look at a given mass. How many forces are there at a given point? 1, 2, 3, 4, 5. Can I use Lamy's theorem? No. Here 1, 2, 3, 4. It is only valid for how many concurrent forces? 3 concurrent forces. I'll go to method 2, where I'll select some axis as x and some axis as y, perpendicular axes, and I'll resolve them along the x axis as well as the y axis. I have resolved them along the y axis as well as the x axis. Now I'll equate them. That is, left is equal to right and up is equal to down. Because they are in equilibrium, means the net force acting on the system is 0. So I can say, look over here, equation 1 will be formed as up is equal to down. So can I say T1 cos alpha is equal to 2 mg plus T2 cos beta? Equation 1. Left is equal to right. T1 sin alpha is equal to T2 sin beta. Equation 2. Over here, up is equal to down. This W, which is mg, and left is equal to right. When I solve 1, 2, 3, 4, I get the answers. Whatever numbers are given, whatever angles are given, we can substitute alpha and beta. Over here, weight is given, and you can solve for T1 and T2. Got it, everyone? Start. So we are doing non-concurrent forces now. Put the first point as moment of force or torque. Moment of force or torque. Moment of force or torque is responsible for rotational motion. Moment of force or torque is responsible for rotational motion. Responsible for rotational motion. How is it? We'll see. Suppose, take some example. Suppose this is force acting at a given point. I want to find moment about this point. Those who don't know, please pay attention. Those who have not attended 11th standard. Either. F. I want to find torque about this point, moment about this point. What to do? Extend the line of action of force. Extend the line of action of force and draw perpendicular distance from here. Can I say this is your R perpendicular? Torque or moment of force, the formula is this. It is R bar cross F bar, which can also be written as RF sin theta, which can also be written as force into perpendicular distance. You will use this. Force into perpendicular distance, because we have made theta how much? 90, na? Theta is the angle between R bar and F bar. So by taking perpendicular distance, I have taken the angle between F bar and R bar to be 90. Okay? Achha, how is the direction of this torque? The direction of this torque, the rotational motion will be clockwise or anti-clockwise. If you take it this way, it will be this way. It is clockwise. How is the direction given by right hand rule? This is R and this is F. This is R cross F, na? So half of your hand will be R. This hand will be F. So it will become R cross F. Where is the direction of the thumb? Inwards. Inwards means minus or plus? Inwards. Minus Z axis, na? Okay, minus axis. Remember, it is clockwise. We have learned in school, anti-clockwise moments are positive. If it is anti-clockwise, it will come out. And if it is clockwise, it will go inside. You do not take so much headache. You can write like this. It is going to rotate this way. Okay? No problem with this. Now if I tell you, if the force is this, find moment about this point. What to do? Why? Because there is no perpendicular distance. If I increase the line of action of force, I can say it is ending over here. So what is the perpendicular distance over here? 0. So torque at this point O will be 0. And the unit of torque, remember, na, Newton meter. If I tell you this, okay, this is this way, and this point, what to do? Line of action of force, so are perpendicular, na? And it is going to rotate this way. So torque will become F into R perpendicular. F into R perpendicular. Getting it what's happening? F, I have increased the line of action of force, and this from this point is perpendicular distance. Na? Got it, everyone? So this is how we calculate torque about different points, and which is very much necessary for non-concurrent forces. Got it? Please make this, then I'll move ahead. As method to solve sums based on non-concurrent forces which are in equilibrium. Method to solve sums based on non-concurrent forces which are in equilibrium. Are you understanding each and every technical language? Equilibrium, net force is 0. Non-concurrent, not at a certain point. Okay. I'll use one method, and that is standard. I've taught you this in the 11th also. Remember the ladder wale sums? This is non-concurrent because in the ladder forces are acting at different points. The same method I'm going to use. Okay. Right? There are three equations formed. First equation, summation fx is 0. Second equation, summation fy is 0. Third equation, summation torque is 0 about any given point. Summation fx is 0, summation fy is 0, summation of moments about any given point has to be 0. Acha, I have spoken about that point also. Which point I should select in the ladder? In the bracket you will write, select such a point where maximum forces are acting. Select such a point where maximum forces are acting. Select such a point where maximum forces are acting, so the calculations will become easier. Okay. Then we can take total anti-clockwise moments at a given point. Equals total clockwise moments at a given point. Total anti-clockwise moments at that given point which you select is equal to total clockwise moments at that given point. Okay. One thing is very important, ये चीज आप ध्यान में रखना. Method is important, sum is not important. By this method you can solve 10 sums. Don't go after the questions, go after the method. I've seen many people going after the sums. This sum is important, that sum is important. Go by the method by which you solve the sums. That's why in every synopsis I give you all the methods, all the shortcuts. then you can do a lot of sums based on this. Your concepts, that concept you have to apply and together mix and solve the sum. If you don't know the method, you will not be able to do the sum. Okay. While practicing also, I have seen people closing their synopsis book and solving the sums. You should keep your synopsis book in front and solve. So that after maybe 100 sums if you solve, वो synopsis अपने आप will be digested inside. Because you are solving n number of sums by that method. Turn pages. Okay, this method we have done, that method we have done. This is combination of that method and this method. Got it? Okay. We'll start with the sum. Example. Look over here. Mass is 6 kilogram and the length is 4 meter. The length is 6 meter. 6 meter. Okay. This is smooth surface, smooth wall, and this is rough wall. Both can be rough also. Both can't be smooth. Then you need ropes to tie them. You are understanding what's happening? If both are smooth, there will be no friction, so there will be no holding. Then you have to tie a rope over here. At the top also. You need tension in the string otherwise. Okay? Now can anyone tell me how many forces are there? I want to find the forces on the wall as well as on the surface. How many forces are there? Weight will be there, obviously, yes. Weight acts where? At the center of gravity? It's middle only. So if I take this as 0 meter and this is as 6 meter, this will be 3 meters. 6 meter ladder, no? Okay. It's uniform, I am telling you. Understand what's happening? Otherwise, if they tell you center of gravity is 1/3 up, 1/3 down, then you manipulate according to that. How much is the weight? 60 Newton. Well, come over here. Reaction force, contact force. Can I name it as N1? Here also there will be another contact force, N2. Smooth, so no friction. Rough, so friction. Where is friction acting? Opposite to intention of motion. Intention of motion is this way. Friction will be this way. So we need to find N1, N2 and F, right? Intention of motion is here. Okay, na? There is no friction here, it's smooth. So this friction and this normal reaction is holding the whole system. Now what to do? Look at this. 1, 2, 3. First method. Summation Fx is 0. Fx is 0 means along the x-axis. Can I say left is equal to right? Left is equal to right. So F will become N2, equation 1. Summation Fy is 0. Means what? Up is equal to down. What is up? N1. What is down? Weight. This is 60 Newton, right? Let's got this answer. Third one. Summation torque at a given selected point has to be 0. Which point will I select? I'll take this point as P, this point as C and this point as Q. Which point will you take? Take point P. Why? Because maximum forces are acting over here. Okay, so moments about P should be 0. What is formula for moment? Force into perpendicular distance. Force into perpendicular distance. And they have given you this angle also as 30 degree. This angle is also given. I missed it. 30 is given. Okay? Acha, now, how many forces are there as a whole total? 1, 2, 3, 4, right? But they will become 0 because force into perpendicular distance at this point is 0. So N1 into 0 is 0. F into 0 is 0. Yes or no? What will be the third force? W. W is vertical. So beta perpendicular distance will be horizontal. Can I say, can you tell me how much is this distance? Beta, this is 3 meter. So this is 30, it will become 3 cos 30. 3 cos 30, right? So it will be W into 3 cos 30, right now? And how is it rotating? Anti-clockwise, right? I'll say anti-clockwise moments is equal to clockwise moments. Who is going to give you clockwise moments? N1, N2? And what is it? What is the torque about this point? Force into perpendicular distance. How is the force? Horizontal. So how will be the perpendicular distance? Vertical. So what is that? N2 into perpendicular distance. You know perpendicular distance will be how much? This is 30. This whole is 6. This whole is 6. It will become what? 6 sine 30. Arey, opposite component is sine, na baba? So it will become what? 6 is the hypotenuse. Sine 30. Yes or no, beta? 3 2s are. How much is W given? 60. Cos 30 is beta root 3 by 2. N2 into 2 sine 30. What is sine 30? Half. Will go. So N2 will become what? 30 root 3 Newton, right? Once you get N2, I can say that is F. N2 is equal to F is equal to 30 root 3 Newton. But if they need the total contact force at point P, अच्छा ये मिल गया N2. N2 मिल गया ना बेटा? N1 I know, F I know, but I need total contact force over here. It will be total contact force over here. F net will become under root of N1 square plus F square. F square na? N1 square plus F square na? So what is the N1 square, man? 60 square plus 30 root 3 the whole square. Root of that, whatever answer comes, that will be answer in Newton. That will be the total contact force at point P. We take a question into consideration over here that if this is the ladder which is there over here and a child is climbing up the ladder. The child is going up. Idhar dhyan dena. Child is going up with constant velocity. What will happen to the friction? While going up, the child is going up, the friction will increase, the friction will decrease, the friction will remain the same, or it can't be predicted from the question. फिर से, child going up, F increases, F decreases, F remains same, can't be predicted. Think. It will increase. Say why? Weight will not increase. Which normal reaction? Increase. Normal reaction is the same. Which moment? Due to the? Very good. So moment will increase. So friction has to increase. Okay, very good. See, what did she say? I'll tell you. As the child is going up, suppose the child is here only. So his weight into perpendicular distance is this much only, na? So the torque will be chotu sa. Force into perpendicular distance is very small, na baba? When the child comes here, force into perpendicular distance has become more. So the torque will increase. Which torque is this? Clockwise, anti-clockwise? So if anti-clockwise torque is more, the clockwise torque has to be more. So indirectly N2 will increase. To increase this, the reaction from the wall will increase, and we know that N2 is equal to F. So if N2 increases, this friction will also increase. Got it? So as the child moves up, the anti-clockwise moments will increase. For that, the clockwise moment also has to increase. For that, the reaction from the wall will increase, and because of this, the friction will also increase. And friction maximum is how much, beta? Mu s n, that is limiting force of static friction. Beyond this, if the friction increases and increases and increases and crosses Fs, then the ladder will slip. You got the whole connections? Got it? Fine. So we can just write a concept that if the child is going on the ladder and moving up, okay, as the perpendicular distance increases, the friction will also increase. Next topic which we are doing is hinge forces. Put the heading as hinge forces. Hinge forces. First point, a rod is rotated. A rod is rotated about the hinge. About the hinge. And if we want to find hinge forces, or the forces exerted by the hinge, on the rod, there are two unknown forces. H and V. H I've considered as horizontal force about the hinge, and V is vertical force about the hinge. So H and V, and the resultant of both of them, F net, will be under root H square plus V square will be the hinge force. Getting it? You can find theta also, because this will be the hinge force, na, F net. Now this angle will be theta, na. Are you understanding what's happening? So to get hinge forces, I have resolved the two forces into H and V have a normal component, and then F net will be the total hinge force, which is under root H square plus V square, and this and theta also you can find. This example we will see to understand. There is a rod of length 10 meters. Okay, can be rotated about a hinge. This can be moved up and down. This is holded by a string at 30 degrees, and the weight of the rod is how much? 60 Newton. They are asking you what is the hinge force. Okay, what is the force applied by the hinge on the rod, as well as the tension in the string. Okay, how to do? Come on, where is the tension? T, na? Yes or no? Come on, tell me. This will be what? Anyone? H? V? Once I get H and V, I'll be able to get the total hinge force. Now I can resolve this into two components. This will become T sine 30, and this is going to become T cos 30. Is everyone getting it? Are these concurrent, non-concurrent? Get the method. Non-concurrent. How many methods are there in non-concurrent? How many steps are there in non-concurrent? 3. सबसे पहले up is equal to down, left is equal to right. Select any point above that torque is 0. Right or not? You all will do? ठीक है, come on, start please. Okay. Same method I have done, only we have just added hinge forces, nothing else. So up is down, left is right, summation of moments about any point where maximum forces are acting should be 0. Why? Because the rod is in the translational equilibrium as well as rotational equilibrium. इसका मतलब क्या होता है? Neither the rod is translating nor it is rotating. So net force is 0 as well as net torque is also 0. Got it now? Concept points. First point. If all non-concurrent forces are unidirectional, if all the non-concurrent forces are unidirectional, if all the non-concurrent forces are unidirectional, then we will have only two equations. Okay, I'll show it to you in the question how it is. We'll have only two equations. Look over here, please. This is a shortcut method, directly we can do. There's a wall, hinge is there, a rod straight to a string. Okay, it's given us 30 degree, that's 6 meters, and the weight is acting, that is 100 Newton from the center of gravity. Okay, now see, I'll make the forces over here. Please pay attention. There will be tension in the string, that is always there. This weight is there. They're unidirectional. Hinge forces are two types, H and V. So this is V and this is H. I can say H is not there only because there is no one to balance it. अगर ये unbalanced force हो जाएगा तो ये चलने लगेगा ना फिर. That means H is not there because the rod is in translational as well as rotational equilibrium. So H is not present only. I can say all the forces are unidirectional. Up is down. तो पहला equation क्या बनेगा? Up is equal to down. That is summation of Fy0 Fx तो चला गया. Fy0 means I can say V plus T is W is 100. Right or not? Yes or no? Second, summation of torque is 0. Summation of torque is 0. Torque के लिए कौन सा point हम select करेंगे? Hinge. So consider moments about clear ना? बोलो क्या करना है? Force into perpendicular distance. There is no need to calculate perpendicular distance over here. Can I say T into 6 is W into 3? देखो ना भाई. अच्छा अगर आपने परपेंडिकुलर डिस्टेंस निकाल भी दिया, सपोज मेरा मेथड क्या कह रहा है, t इंटू 6 इस w सेंटर ऑफ ग्रेविटी पे एक्ट करेगा ना बेटा, ये 3 होगा ना, यू गेटिंग इट व्हाट्स हैपनिंग। सो ये क्या हो जाएगा, सो t w इज व्हाट 100 का t विल बिकम व्हाट 50 न्यूटन। क्लियर है? सो आपको ये 50 मिल जाएगा, सो v भी कितना मिलेगा 50 न्यूटन। सपोज हम नॉर्मल मेथड से करते, we used to do by which method, normal method. Can anyone tell me how much will be this perpendicular distance beta? 6 cos 30. How much will be a weight का perpendicular distance? 3 cos 30. अच्छा cos 30 cancel. अरे भाई this will come 6 cos 30 and this will come 3 cos 30. So no need to take any that tension which is there. Whenever it is unidirectional, there is no need to calculate perpendicular distance. You can calculate along the length. Can I say F1 L1 will become equal to F2 L2? Got it? Start, come on, please.
Thank you.